All right. Did you guys come with questions right now, or people who are here get the first go if you have a specific topic that you want to bring up?
Not yet. I mostly came to observe and see if anybody else brought up some good questions.
Okay, there are a couple posted on the help forum, so we'll start on those. We'll give you guys just a couple minutes if anybody else has anything they want to say. And otherwise, and then make sure if you are, putting an official question out there, just type in the chat also, just because I will have that as a record at the end, and I don't want, participation to go by the wayside. The questions that we got in the forum, specifically, someone was asking about significant figures and rounding. And I think the question is do you round up or something because of your significant figures? So I do want to just talk about significant figures. Have you guys gone over the videos? There were videos attached to the lab to give you guys your background. So those go over your concepts of significant figures. So significant figures and rounding are kind of independent. Your significant figures, if you think of the English version meaning of the word significant, it's the things that matter, right? So when you're doing a lab, and this matters a little bit less, if you're just doing math or whatever, if you get, 2.13 or 2.1379 or whatever, your teacher doesn't really care because she knows that you went through the problem and you got the right answer, right? The sciences, and particularly lab work, are a little bit different because the difference, if you got 2.34 or 2.341, those are actually two different numbers, and that little one at the end means that you measured another extra piece of accuracy. So we are pretty strict about significant figures. And I remember, I've seen a lot of people go through math class, and a lot of times they give you rules for significant figures, but they don't tell you why that matters. The reason why it matters is because the extra numbers that you have are making a declaration of the accuracy of the measurement that you took. So if you have, just two numbers or three numbers or four numbers, the difference between measuring, say if you're measuring with a centimeter ruler, you might have 2.5 centimeters, right? If you have 2.5 centimeters with two more sig figs, that means that you have something that can measure the accuracy of 1/10 of a millimeter, which is a completely different piece of equipment than a centimeter ruler, right? So it's actually, it says something about your equipment and about the situation that you're measuring. So sig figs, just like the number of numbers you have, are just an expression of what degree of accuracy you're using when you're making that measurement. And that's why they matter, and that's why we care whether you're using 2 or 3 or 4 in the lab class, when we wouldn't really care that much if it was just math or something. Does that make sense?
Yes.
Okay, so the rules of rounding don't change at all. So if you have a number that you're rounding, and you do round, and this is another time where kind of how you do it in lab matters. You carry out all of your decimals. If you're making a complicated calculation, or you're going to have a number and then you're going to do another few steps and get different numbers as you go along, while you're calculating, you always keep all of those numbers with you. So if you have 8 or 9 or 10 numbers trailing across your calculator screen, you just keep all of those all the way through all the steps that you're doing. But when you report your final number, whatever the thing is that you're measuring for your lab, you actually need to look at your lab and think about the number of significant digits that you can actually report, because that number is saying how precise your measurements were. So unless you have, there are detailed rules, and the videos get into those about sig figs. But one kind of rough number, especially if the calculations you're doing are multiplication and division, a rough rule is the same number of sig figs you have going in is the same number you should have coming out. So if we go back to that example where we're using a centimeter ruler, if you're using a centimeter ruler, you should probably at least go down to millimeters. And usually, depending on how careful you are, you will have the last, when you're eyeballing your millimeters, you're like, oh, it might be between the 3 and the 4. And you can eyeball whether it's right smack dab in the middle or closer to the 3 or closer to the 4. So that last number that you're recording, your fractions of a millimeter, maybe, depending on how sharp your sample is, whatever it is you're measuring. If you have something fluffy, for example, you're not going to be able to eyeball a fraction of a millimeter on that, right? So the number that you can get, even with a specific piece of equipment like a centimeter ruler, it really depends on your situation, on what the material is that you're measuring, and as well as the equipment that you're measuring with. So the last number, your last significant digit that you're reporting, is always got to be something that you will have to make a judgment call on. So you can probably get exactly the right centimeters. Nobody's gonna like argue with you whether it's 3 centimeters or 4 centimeters, right? Like that's gonna be an easy judgment call to make. But you will go as far as you can. If your sample and if your situation is rough enough that an even millimeter is the best that you can get, then you'll measure to millimeters. If it's a fraction of a millimeter, then you'll measure to a fraction of a millimeter. And that last thing is always a judgment call that you have to say, ooh, does this look like a little bit more or a little bit less? And that's your least significant digit. So that's how you know if you've measured far enough, is that you always, on the very last one, you're going to make the judgment call. It's going to be a judgment call that you can make, right? You're not going to be making anything up, but you're going to have to be eyeballing your least significant digit. So you take your measurement, you make that judgment call, and you report as many numbers as you can and not more. That's how you know how many significant number digits that you have. And when especially when you're using metric, but in any case, the numbers, whether they're before or after the decimal point, just depends on what unit you're using, right? So that fundamentally doesn't change. And that's one reason why we choose to use scientific notation, because that says the decimal point always comes after your first number, and then you just have so many numbers after the decimal point, and then you choose the unit that gives you that result. So if the measurement you're taking is in centimeters, you have like whole centimeters in front of the decimal point, then a decimal point, then numbers after. But say it's something weird, like 10 to the 5th meters or something. Well, you don't have a special unit for that. If you go into your Latin roots, you might be able to find one. But we prefer to just pick meters, say we're always going to use meters, and we're always going to put the decimal point right after your most significant number. The very first number you get, the roughest measurement that you have is the most significant, goes down to the least significant digit. So you put the decimal point after that most significant digit, and then you use scientific notation, which is just something you multiply by, right, to give you the actual number. Use that scientific notation to put all of your numbers in the same format. That's why it's used. I'm hoping that makes a little bit of sense just in the context of measuring something in a lab. You are supposed to have background in the videos, but they might have probably explained it differently. Okay, so I'm seeing chat messages. All right, so if you got 258.34 to make two significant figures, is it 2.6 times 10 to the 2 or 2.5 times 10 to the 2? All right, so that's a good question. That gives us a good concrete example of our rounding question. So the numbers 2, 5, 8, if you're going to take the two most significant, by regular rounding rules, you judge by the 8, and it will round up to 2.6, just like it always would if you rounded in any case. So there's no special rule with your scientific notation that it changes the rounding rules. You just choose how many digits matter, and you take those. And then you get the times 10 to the whatever to move your decimal point to the right place. Okay, is that clear? Do we need to elaborate? Okay, so people are asking on number 20. I don't have the lab memorized, so I can go dig it out. and look at number 20, or if you guys just want to tell me what number 20 is. And just in general, it's always good to ask, hey, I had a question on, how to calculate force, or how to do this, how to do that. If we're just saying, oh, I had a question on number 20, that's usually it's a sign that if you thought about it a little bit more, then it might formulate something more clearly in your head, hopefully. All right, so is this number 20 that we're talking about? As of summer 2020, Voyager 1 is 13.8 billion miles from Earth, expressed in AU. Is that what we're talking about? Okay, great. All right, so we will pull, if I pull our whiteboard onto the other screen, can you guys still see it, or did it disappear?
I can only see where you gave the announcement of the new Zoom
Okay.
link there.
All right, I am just going to change my screen sharing just a little bit so you guys can see what we're working on as we work on it. Okay, now can you see it?
There we go.
All right, great. All right, so we'll do our calculations here. So this is basically a unit conversion, which is kind of the other main concept we're going on in the lab. And the unit conversion is 13.8 billion miles. So a billion is times 10 to the 9th miles. So this is the number we're starting with. And we want to convert it to AU using two significant figures. So we started off with 3. We're allowed to round down to 2, but as we mentioned before, the rule is to keep all your significant figures through all your calculations, and then you round at the very end. So that's something we'll need to worry about when we get our number. All right, so the big question we have here is, what is an AU?
Aeronautical mile, or unit, I'm sorry.
Yeah, it's an astronomical unit. It is the distance between the Earth and the Sun. And it's like a standardized mean distance. You might know, if you know a lot of astronomy, that that actually varies a little bit. And I believe in the lab, they probably gave it to you in meters first. So we will, this is actually kind of a compound unit change, and I will go ahead and show you the multiple step one. You could just convert it straight to miles if you had the right conversion factor. But in the lab, is it given into you in meters? Okay.
I think above, does it say 150 million meters? Am I quoting that right? I don't have it in front of me either.
All right. Is there another comment? Go ahead.
The question is in miles. It's not in meters.
Yes. Well, what's going to happen is we're going to need more than one conversion factor. So I'm going to show you guys how to do it with more than one. If you don't have the particular conversion factor that you need to go straight from astronomical units to miles, which you usually won't, because astronomical units are a kind of an SI thing. And so normally your conversion there is going to be in meters. And then if you want something like miles that we only use in America, you're going to have to do a separate conversion there. So I'm going to show you guys how to do that. Okay, so 1.496 times 10 to the 11. This is meters per AU. So this is called a conversion factor. You notice that the units right here are in fractional form. Normally, they don't necessarily give you directly a conversion factor. What they'll just say is 1.496 times 10 to the 11th meters equals to 1 AU. So you have an equation, but the way of doing a unit conversion that makes the most sense to the most people, and there are actually multiple ways of expressing this. You might see different teachers do it different ways. But I like to go back, hopefully you in your math class, you learned identities and stuff, right? It's a little bit mysterious. Sometimes we're like, oh, we'll never need to use that again. But your identity property is that if you multiply anything by 1, you get the same thing back again, right? And that's like just a rule of the universe. You use it if you do proofs or whatever. You may or may not have used that in math class. But we all know if we multiply something by 1, then we get the same thing back again. So if we have some, let me get one other conversion factor. We're also going to need the conversion factor of meters to miles, right? And I don't happen to have that off the top of my head, so I'm going to get it real quick. And we're going to need that one too. So we also have 1 mile equals 1609.34 meters. Okay, so these are 2 facts. You might get it in equation form like this red one that I just wrote out, or you might get them in a conversion factor like this, like the one above that's just a number. And that's just a fact that you need to convert your number from one set of units. We started off in meters per AU, and we have something we know that we're going to have to convert miles to AU. So what you do is we have this number, our top number here, and it's in units of miles right now. So we want something to multiply it by. That's the number 1, because we know that gives us the same thing back. We don't want to actually change our number that we're working with, right? But we want something that will change the units. So we want something with miles on the bottom to get rid of those miles that we have up here. So if we want, for example, this red equation right here, we want to change it into something that has just a number, but with fractional units on it, that will get rid of miles and will give us meters instead, because this is going to be a 2-step process. Okay, so if 1 mile equals 1609.34 meters, that implies that your conversion factor, and a conversion factor is just a number that's equal to 1 equals 1609.34 meters divided by miles. You're just allowed to move the miles to the other side by dividing both sides by miles, right? If you remember your algebra. If this was more complex, say you had miles to kilometers and you had a number close to 3 on one side and a number close to 5 on the other side, you might end up with 5/3 miles over kilometers or something as your conversion factor, or 3/5 or something like that. So you won't always just get this number that looks exactly the same as your conversion factor. But this is your conversion factor. That's just a number that's equal to 1. So we have a choice to make here now. We can either multiply our original number by our conversion factor, which will give us a number in meters out. It will get rid of our miles for us, and it will give us our meters, and then we can convert it to AU, or we can do it all in one step by using another conversion factor. So it's completely valid, and I like to do your light year calculation. I don't know if you guys all managed to do your light year calculation, but you can do your light years. Light years, the speed of light is usually expressed in meters per second, and people are sometimes giving you light years and conversions to miles or something. So sometimes you can use that calculation there and use how many minutes in an hour, how many hours in a day, and whatever, and you can have like 6 or 8 conversion factors all in one calculation. You just multiply them together, and if you keep track of your units and you cancel out the ones you're not using, it spits out your answer in the end. So that's a completely valid thing to do. You can do it in multiple steps, or you can do one multiplication, get it out in one set of units, which you guys, I think, actually might need it in meters in this lab. I'm not sure if we simplified it. We took out that question perhaps, but you might need a number that tells you how many meters in an astronomical unit, or you can just have it convert the whole thing for you. But let me back up here. All right. So right now, let's just take this top number up here. I'm going to widen the screen. I might have to use, there we go. Sorry, this is a little bit harder to do without my regular mouse that I'm using. So this number right up here is the number that we're using up at the top. We're going to get rid of that. And we're just going to multiply it by this number 1, the conversion factor that we figured out before, which is this number down here. And I'm going to get a slightly bigger pencil. Not quite that big though. All right, so if we multiply 13.8 times 10 to the 9th miles times 1609.34 meters per mile, which, like I said, this is just the number 1. Then what happens if you have miles on the top and miles on the bottom? This is a fraction with miles on the bottom, which means you divided by it, right? So those miles cancel each other out, and you just end up with this 13.8 times 10 to the 9th times this number right here, and your unit will be meters. So if anybody has a calculator on them, you can do that. Normally in a classroom, we have everyone out with their calculators working on this, but I don't know where you guys are all coming from, so that might be a little bit harder to do. 1609.34. Okay, and I am going to show you guys another step how to handle the scientific notation too. So if you just do this multiplication, say that you don't have a calculator that you can do scientific notation on, or you don't know how to use it or whatever. So this is just a factor that you can multiply, right? So if you could do this number, the 13.8 times the 1609, you get 22208.892. And remember, we keep all of our numbers. I might not always write every single digit out on the screen if I know that we're going to lose a whole bunch later when we round it. But I like to keep plenty as I go along. So this is a number, and then we know we have a lingering times 10 to the 9th here. So if we're not going to be reporting this number, because this is still in units of meters, but how would you handle this number if you want to put it in scientific notation? Normally, scientific notation, we always want our decimal point right here, right? And it's kind of in scientific notation in that we have a times 10 to the 9th out here. But basically, all of these numbers here, after the decimal point, we want the 2, the 0, and the 8. We want to include those over here, right? Instead of on this number. So what will that involve? That will involve moving this decimal point over 4 times, right? So if we want to move the decimal point over 4 times and put it right here, then what do we need to do to this number to make that still be true fact, the same number?
Increase it by 4.
Yeah, so the 9 is just the number of tens that are inside of that number. And we wanted to move these four tens right here over to that number. So yep, 100%. This becomes times 10 to the 13 now. Because we want all of those extra, because we want the decimal place right here, we want all those extra zeros to be inside of our exponent. So it's times 10 to the 13. All right, and we still have the unit of meters here. Okay, so what are we going to do to get rid of meters? We're going to times by one more conversion factor, and that's this one right here. Oh dear. Sorry, I was a little too close to the edge of the screen and the computer thought I was doing something else. So we have the number of meters per AU. And that's not quite the right conversion factor, right? We want something with, we want to get rid of our meters, so we would want meters on the bottom. So we can either put this back in equation form and divide it to the other side to get something with meters on the bottom, or what happens if you divide? So right now we have 2.2208 blah, blah, blah times 10 to the 13 meters. If we divide that by 1.496 times 10 to the 11 meters per AU. This might be a little tricky. I don't know if you guys know what happens when you divide by a fraction. You should from your math, but sometimes we forget. So if you have meters divided by meters, those will go away, right? And if you have one divided by 1 over AU, that will put your AU back up on top, which is the same math that you would get if you put this back in equation form and figured out what your actual conversion factor to get rid of meters would be. So 2208 times 10 to the 13 divided by 1.496 times 10 to the 11. So if you get 10 to the 13 divided by 10 to the 11, what do you get? That's just going to be 10 to the 2. And remember, your 10 to the 13 is 10 times 10 times 10, 13 times, right? And so if you divide that by 10 to the 11, 10 times 10 times 10, 11 times, you have 13 tens on top, 11 tens on bottom. You're left over with 10 to the 2. Okay, and then you would type it into your calculator, 2.2208 divided by 1.496. And the answer there is 1.48449. We know that we're only going to want it 2 sig figs, but we put a few down and then we're going to simplify it, or round it rather. Sorry, this is a little bit ugly. I might take one of those off so it's not quite so ugly. There you go. 1.4844 times 10 to the 2 astronomical units. All right, so do we believe that? If we go back, and this is, if you guys have seen your problem solving checklist. Also, we do have a time meeting. I just noticed the 10-minute warning on our Zoom meeting. If Zoom kicks us off, just go back and use the same link, log in again if we're still in the middle of something. Hopefully we'll finish it, but. Okay, so if we're 1.48 times 10 to the AU, does that sound realistic for the answer to the question, which is where is Voyager 1 in 2020? So what kind of number is 1.48 times 10 to the 2 AU? That's 148, right? So 1 AU is the distance from the Earth to the Sun. The solar system goes up to about 30 AU, and Voyager 1 has been traveling since the 70s trying to get outside of the solar system. So yeah, it sounds pretty plausible, right? And that's kind of a logical check that you always do when you get to the end of your problem. Does the results of the math, because we had enough steps in our math, we could have made a mistake, right? So we go back and we double check to make sure that it makes logical sense what the answer we got. Okay, there we go. All right, so then we will need to round it down to your 2 significant figures that are asked for in the problem before you would actually enter that in to as your answer. So that rounds to 1.5, right? And you still need your times 10 to the 2, and you'll need to enter that in and exactly the number of spaces and everything that they asked you for so the computer can understand it. All right, does that make sense? Does everyone kind of see the logic? Sorry, our whiteboard here is quite a bit messier than a real life whiteboard would be. Don't love it, but that's the format we've got. Okay, so I don't know if my sound is still working. I cannot hear anyone. All right, feel free to chime in.
Can you hear me?
Okay, now, yeah, I could hear one person just now.
Okay, awesome. Yeah, I originally had put 1.5 times 10 to the 2 AU, and I had it spaced right because the other questions I got were right, and I did the same spacing, and I got it wrong, and that's why I was confused about this one question, because I did the same work that we just did right now. Then I was confused if I was rounding the wrong decimal, the wrong place value, if I should have done two.
Okay, yeah, so this, unless we've made some egregious mistake here, this is the right answer. I will go in, it is a quiz that's been used before, so there shouldn't be any typos left in it. But if, especially if we meet together and we have a particular answer and we came out wrong, I can always go back and just manually look in the quiz, see what the problem is, and I'll make an announcement about that. It'll take me a minute to look at it, make sure. But everyone, well, I will probably, if that is an error in the quiz, I will just have to manually grade that question for everyone. But since that's a question, I will post in an announcement on it what the story is.
Right. I've submitted the quiz twice now. So I did 1.5 the first time, and then I'm like, well, I must have rounded wrong. So I did 1.4 the next time, still wrong. So I just wanted to make sure, but I'll try to go back and do.
Yeah, no worries. At this point, the most likely situation is that there's a typo in it.
Okay,
so I will probably just look at it, verify that, make an announcement, and just grade it by hand to make sure everyone gets credit.
Oh, thank you. And then just one more question. So when we're doing the conversions, I did the same problem. I had to like Google what an astronomical unit was. I looked at the video. That information was not on the videos, right?
It should have been. I can
It was
also
in an earlier question. I think it said like 150 million meters. I'm looking for that right now.
Okay, that also could explain it. If we give you the conversion factor and sometimes it's just this tiny bit different. If we give it to you in different sig figs or something, it can change your answer just a little bit. And I don't have this quiz memorized. So if we used a slightly wrong conversion factor, it would give a slightly wrong answer or a slightly different answer rounded differently. And that might cause you to have like not exactly the same number the quiz did. So that could very easily be the cause, in which case I would just verify that in an announcement too and just tell you, make sure you use this particular conversion factor when you do the problem. All right, any other questions? That seems to be the tricky one, was number 20, and there's a reason why it's tricky, and so we'll give everyone notice on that, and if we need to give points back, we will.
Thank you.
Okay, so it seems people are generally understanding the rounding and the astronomical units and the conversion factors. It's just a little tricky with the particular one they asked you to use in the quiz, then probably causing the issues.
Yes.
All right. Well, great. That like I said, I will find the exact cause and clear that up in an extra announcement. But it looks like people are not as confused perhaps as it looks like originally. So that's good. Sorry to be the cause of that though, if it's just a typo in the quiz or something.
Thank you. And I have a question for the next assignment, next quiz. So do we have to make a group by ourselves, or are you gonna make a group? Then we're gonna.
So officially these, especially the online ones since COVID, you're not required to use a group. So originally this class was designed for like 6 lab stations in the labs, in the classroom. We're not doing that. So if you actually know someone, like there's people who were roommates or whatever who took the class together in the past, but for the most part, online people don't opt to do it in a group. So you just complete it on your own. It's easier for people to just do that than actually try to find someone to meet with in the middle of COVID. So you may choose to do it in a group, but that's not usually how it's done.
Okay. Okay. So if I have someone to know, then can I make a group?
Yeah, if you
Yeah.
know someone from the class,
Yes. Yeah.
and I think I actually published directions on how to do that. Just submit one copy of your packet that you made together, and make sure that both people's names are in the comments section. And that's just how I handle it in all of my classes where there are groups, to make sure that everyone gets a grade, but that it's clear who was participating in any particular submission.
Oh, okay, I understand. Thank you.
All right, any more questions? All right, we'll wrap it up. Okay, sorry, go ahead.
Sorry, I actually had a question about question number 22.
Okay, and how does that go?
It says the average distance between the Sun and Neptune is 4,450 times 10 to the 6 kilometers. And then it says express the distance in AU with two significant figures. And when I calculated it, I end up with 29.7. So I put 30 as the answer, but I counted it wrong.
Okay, so, and it said specifically 2 sig figs?
Specifically 2 sig figs, but it won't,
Okay.
it says numerical answer only.
Okay, so if it says numerical answer only, that might be that they're implying that the units are already in there, and so you don't type out the AU and whatever, you just put the number. So just put 30 and push enter. Is that what you did?
Yes, I put in 30 and I counted it wrong. So I was kind of confused on why that was counted wrong.
Okay. Send me an email on that, just like the other one. I will go in and see if there's something wrong with the quiz, or if there's like a little conversion factor difference or something that we should be accounting for. I suspect on that one, it's a format issue, that there's, the wrong number of spaces or whatever in it. That the computer
Yeah,
is
because
looking for.
30 is correct on that one.
30
Yeah,
is correct. Okay.
yeah. So just if you put 30 in and it has an extra space or something in it and the computer's not accepting it, go ahead and just email me and I can go back and grade it by hand and give you the points back.
Okay.
That's
Awesome.
just in general on this one.
Okay.
Yeah, on that, yes, actually, on that question, actually, I did the 30, but that's kind of rounded up question. So if you